Rightio, let's just check. Everyone paying attention? No? No? Karen talking? No? Good. Right, what's that? Pardon? Root 2 over 3, you think?
No, that's it. I think it's
1.
It's 1 over 2. 1 over third 3.
1 over root 3, you think? What do we think? I hope those are maths cards you've got. Yeah.
1 over root 2.
How do we know? Is it 1 over root 3?
Well, I know, because you use the triangle.
Yeah, that's what we're using, aren't we? It's 1 over root 3. Yeah?
Yes.
What is cos of 60? A half. What is sine of 45?
Wait, why isn't that one 2 over root 3? The cos.
Use the right angle triangle.
Cos of 60.
Oh, the right angle triangle.
1 over root 2. Because if it's
opposite,
1 over over.
It's not.
It's
Cos of 60.
Oh.
It's adjacent.
Okay.
What's sine over 45? Sine of 45? Pardon?
1 over root 2.
1 over root 2. Okay. So, how do we know? So, tan of 30, tan of 60, they're going to be which triangle?
The equilateral.
The equilateral one, because the angles are 30 and 60. And 45 is going to be the right angle that's 1 root 2. That's how we kind of remember them. Okay. What we'll hopefully do, well, not hopefully, we will do at some point, just not now. We'll look at figuring out what the sine of minus 45 will be.
Is it negative 1 over root 2?
It would be negative 1 over root 2.
Good job.
Okay. We'll look at what cos of minus 60 would be.
Negative 1 over 2.
No.
Negative 2 over 1.
Negative 2.
2 over 1.
It'll stay the same.
2.
Half again. Why? Well, when we look at the graphs and things, you'll understand why, but there are other values that it can be. Okay? So what we'll be looking at, for instance, if we try and solve cos of x equals a half, okay, there will be lots of values for x. There won't just be one solution, there'll be actually an infinite number of solutions that we would be able to find. So we'll talk about how we need to limit the domain of the function we're considering to limit the number of solutions. But that's something we'll be moving on to at some point. Right? But at the moment, to be able to remember those values, tan of 30 is 1 over root 3. That's a good start. Okay, so what we're doing today is figuring out when we've got a triangle, what happens if it's not a right angle triangle? Can we solve for lengths of it? So we're looking at solving non-right angled triangles. Okay. Alright, so this is not going to be obviously, well, what are we not going to be able to use? Pythagoras' theorem or trigonometry is broader than what we've just done, but just the ratios, the SOHCAHTOA stuff. We're not going to be able to rely on those ratios anymore. Okay. So what we'll have is if we've got a non-right angled triangle, right, and I'm going to label it A, B, and C are the angles. Right. Now this is quite important now. If the angles are labelled capital A, B and C, I'm going to label the sides A, B and C as well. And that helps us with the two rules that we're going to be using. Right? So what we do is this, we say, well, if this angle is angle A, then over here is side A, and I use a small a. Okay. So if that's true, what's this side called? C.
Small c.
Small c, although you can't tell the difference. This side will be side
Small b.
B. Okay. Small b. Alright. So that's what I'm labelling them. Now obviously that could have been anyway, I could have done A, B and C at different points, but what we need for these rules is we're considering pairs. We need to consider pairs. So for instance, angle A has to go with the side opposite it. Angle C has to go with the side opposite C, and then angle B has to go with that side opposite. So it's all about opposites, angles and sides. And just like with Pythagoras' theorem and just like with the trigonometric ratios, someone did a bit of research, they did a bit of an investigation, they explored the relationships between the sides and angles of a triangle, a non-right angled triangle. They were using trigonometry, I guess because they'd already got trigonometry, trying to figure certain things out. They were probably cutting it up and that kind of thing. And they came up with a couple of new rules. Now, one of the rules that they came up with, which is quite useful, is that if you take the sine of A, that angle, do you remember what that was? It's just a number. And it's got to do with, if we have a right angled triangle, it's the ratio between sides, the opposite and the hypotenuse. Now, obviously we haven't got a hypotenuse and we don't have an opposite, but we can still do sine of whatever the angle is. But if we take that and we divide that by its opposite side, we get a different ratio. Okay. So at the moment that is just a number as well. But what was discovered was, well, that will equal the same thing if I do sine of B and divide it by B. I'll get the same value. Okay. And what do you think also will be the same if I do sine of C divided by C? Okay.
Everything equals sine.
It's all sines. So if I take the sine of the angle and divide it by its opposite side, I get a number. And that number will be exactly the same for every angle with its opposite side, or the sine of it. All right. Now this is called the sine rule. And I can use it to solve different things with a non-right angled triangle. Now what do you think? Do you think that would also be true for right angled triangles as well? Well, I know why you're saying no, because it would make sense that if it did, then we would have learned it for right angled triangles. But the reason why it does actually work for right angled triangles as well. The only reason I don't tell you it is because it's a bit more complicated and you don't need it to solve right angled triangles. You can use it to solve right angled triangles as well. Alright? You just don't need to. The trigonometric ratios are a simpler way of solving for right angled triangles. But you can use sine rule for any triangle. Alright? Now, you'll discover that there's got to be a certain situation to use sine rule. Right? Certain things have to be true. Right? So what we'll do, before we move straight on to cosine rule, we're going to do a couple of questions on sine rule, so we can kind of discuss when would we know how to use sine rule. When would we know when to use sine rule, and then how would we do it? So if you turn to page 585, you'll look at the green box, and there's something else that we can consider. Because in their little green box, they've got an or. Okay. Page 585. So they've got an or, and they've written sine rule another way. They've done it upside down. Now, would anyone like to offer a reason why it's allowed to be written the other way up? Give an example of why that works. No ideas? Yeah.
If they're all flipped, then it's okay.
Yeah, so if they're all flipped, it's okay. It has to be all of them to make the sine rule. You can't mix the two ways up. If they're all flipped, it works. And let me give you an example of why that works. So, for instance, what if I'm dealing with, well, what is sine A over A? What do we call that? It's a fraction, a ratio, a quotient, whatever you want to call it. If I look at it as a fraction, what if I were to write what if sine A over A was like saying a half? Yeah? That's a fraction, isn't it? And that equals something else with different numbers. Give me different numbers that's the same as a half. 2 over 4, okay. And that equals a third one. Give me another one. Pardon? 4 eighths, okay. Okay, so those statements are true, yeah? What if I write them all upside down? Okay, so here's the thing. I'm not saying that that and that are the same thing. They're definitely not. They give me a different answer, don't they? Because all of these are equal to a half, which is what we start with, but all of these are equal to 2. So they're different. Each one's different, but that's not what I'm saying. When I can write sine rule upside down or not, I'm just saying that those three things are equal. Alright, so I'm allowed to write sine rule, sorry, I'm just going to delete this, either way up, and it still works. The question is, why might I want to? Has anyone thought about that? Why might I want to do that?
Maybe. I have an idea, but I'm not sure if it makes sense. Maybe if you're looking for either the length of the line or the angle of that sort of like
Yeah.
letter. So say if the sine's on top, you're looking for that one, so you're looking for the angle, and then if the sine's on the bottom, you're looking for the length because it lays on the top.
Well, I couldn't have said it any better, so it makes perfect sense. Yeah, well done. If you want to know the angle, if the angle's the unknown, you want it on top of the fraction. It's just easier to find it. You don't need to, but it's easier. Okay. If I want to find the length, the missing length, I would write it where the length is up on the top. Okay. Because we're going to have to do a bit of rearranging to solve for the unknown. Like I said, you don't have to do that, but it just makes it a bit easier. So let's have a look at a question. All right. Let's have a look at example 5 on page 586, and let's go through it. Alright, so what we're looking for is not just how to do it, but when would I know sine rule is the thing to use. Okay? Because quite often in questions, you have to use sine rule and cosine rule in the same question. Right? So we've got 18 meters. That's 41. That's 13. And I am being asked to find BC. Okay. Now, of course, because we're in the sine rule chapter of the book, I know I'm going to use sine rule. but the idea is for you to think, when am I going to use sine rule? Because why would there be a cosine rule, which is coming next, if you can always use sine rule? So let's write this out for how to find BC. What do we write? It's an example in the book. Feel free to read the example if you want. But,
You put BC on top.
so BC is what we want to know, and BC is a
Length.
Length.
Side.
okay. Which is the opposite side to BC?
A.
A. Okay. So, as you said, Layla, the unknown is the BC, the length. I'm going to call it A, maybe. Right, makes sense. So, what would I write now?
BC over
Okay.
113.
Sine of 113. Okay. Equals
18 over sine 41.
okay.
Why would, oh, and then you would have to put the C then.
Equals C over sine C. Okay. Now here's the thing. When we need to solve something, we only need it to be equivalent one side to another, so we've got a value to solve it for. So when we use sine rule, we actually don't need all three parts of it. We only need two parts. All right? So in this case, I don't need that piece of information. All right? I'm only going to use this bit. All right? I only need that bit. All right?
Will it change your answer if you get rid of one?
No, not at all.
But you can use the other one to check.
Okay.
Well, we don't have the information. Why
But
is
if
that
we
not
did?
working? Yeah, I mean, if we've got lots of information, I could check it with it. But there's the thing. So it works. I've got enough information, all right, and I need to solve for BC now. How do I do it? Leila?
Do you move it around?
Oof, don't like your words, but
Don't move it, make BC the subject.
yeah, that's it. Do you have a question or a
No, I
tell me how to do it?
Since the triangle equals 180 degrees,
We could actually. I could solve for this angle as well. Why is it? Oh, no. I could solve for that angle, couldn't I? Is that what I'm after, though? No, I don't want to know that angle. I want to know this side. So I don't need another angle. This bit's gone. I don't need to know sine C. I just want to use this piece of information. So as Layla said, we need to rearrange it to make BC the subject. So Layla, carry on if you want.
So you will multiply sin 113.
Yeah, so I'm going to multiply both sides by sine of 113. So that side and that side. And it becomes
BC equals 18 times sin 113 over sin 41. Why would you put it there? Does it matter?
why would I put it where?
On the top.
Well, when you multiply a fraction by a number, which part of the fraction do you multiply? So again, if I do 3/5 times 7, how do you do that? What's another way of writing 3/5 times 7? Do you know the answer to 3/5 times 7?
Times the top.
21 over 5. So you would do 3 times 7 over 5. Okay? So when you multiply, you just multiply the numerator. So that's why I've written it like that, because that's how you multiply with fractions. And sine of 113 degrees is just a number. Sine of 41 is just a number, right? There's nothing magical about those three letters. Okay? And that tells me what BC is going to be. So, over to you with your calculators. Why, by the way, did I do 18 times sine of 113 again?
Because 18 is the number. Is it?
They give you 18.
Because 18 is the
Why didn't I do sine of 113 times 18? We did talk
Because-
about this.
Sine, wait.
It's purely so it doesn't get confused with its sine of 113 times 18, yeah? I just want the 18 to be separate from that sine, alright? Because in the future you will get to a stage where it is sine of something times something, alright? So we need to keep that separate. So what do we work out BC to be? 25.26. So 25.3.
No, it's, well, it was two, it was 25.3. It was and then they rounded, yeah.
Well, if it's still 25.3 then, yeah? It's 22.555.
You only wanted one decimal place?
I want to 3 significant figures.
Oh,
Yeah?
yeah, then that's right.
So 20. What we should check is, does that make sense? Is that a reasonable number?
Wouldn't it be 2 then? I mean, never mind.
What if you do 5?
So, right, they've done it differently. They've done it to 2 decimal places, but normally we would ask for it to 3 significant figures. So what do we get? It's actually 25.2555. Okay. Well, when I round to 3 significant figures, I want this one, and this one. So I get rid of them. Does this round me up or not? It does. So 25.3. Yeah? So 3 significant figures. I check the triangle, and does it make sense? 25.3 compared to the 18 that I've already got. Yeah, makes some sense. Okay, so that's how I use the sine rule. Okay, what I'm going to do is I'm going to pick one from cosine rule, not because I want to do cosine rule with you. I just want to show you the situation where you can't use sine rule, and then you're going to go on and practice a bit with sine rule before we do cosine rule. Yeah.
What's the difference between cosine and sine?
I'll tell you. It's a different rule. It's a different relationship.
Talking about cos.
Well, it's a completely different rule. It's not cos of something over something. It's a completely different relationship. It looks much more complicated. Sine rule seems quite an easy one. But what we have to do is we have to figure out when we would use it. So I'm going to draw another triangle. Remember, this one will be, well, I can tell you now, it will be cosine rule. But what I want to do is show you why we wouldn't use sine rule, or why we couldn't use sine rule. So this angle is 38 degrees. This is 10 meters. This is 12 meters. Okay, and I am being asked to find BC again. So I've got A, B, C, and I'm being asked to find BC, or A. Okay, so let's just write sine rule out again. So what is it? So BC over 38 equals 10 over sine of C, which equals 12 over sine B. Okay, what's the problem?
You can't cross anything out.
We can't cross one out, but also, let's say I do. Let's go, I don't want to use that one. Let's just forget about it. And let's just use this. If I wanted to rearrange that now to find BC, what's the problem? There's too many unknowns, isn't there? Right? I've got sine C is also an unknown. And as Ali tried to work out the third angle before, I don't have enough information to even do that. You know, if I did, I could sort that out, but I don't have that information. So that leads us to kind of a rule that says to use sine rule, I must have what? Not just values, because I've got values, but we must have
At least two angles.
well,
Or no, or two
we don't necessarily.
major angles.
We must have what we say is a complete pair. So do you notice how for this one, look, this triangle, I had 41 and I had its opposite side of 18, which gave me 18 over 41. It was a complete pair. It was the side and its angle, right? I also must have the opposite of what I'm trying to find out. Does that make sense? If I don't have that information, I can't use sine rule. So we should probably write that down. Okay? So, to use sine rule, rule number 1, you must know the opposite. Now, I say that because if you want to know the angle, you must know its opposite side. If you want to know the side, you must know its opposite angle, right? So you fill in the blank. So, angle, side. Okay. And also, you must have a pair of side and angle. If you don't have that one of those things, you can't use sine rule. But that's fine, because if we don't have it, then we'll just move on and we'll use sine rule, or cosine rule, sorry. Right. So what you can do now, before we have a go at cosine rule, you need to have a look at exercise 29C.1 and probably 29C.2. Let's have a look, page 588. And what you need to do is you need to use sine rule to make sure that what we've done is quite easy. We've solved for a missing side, but you also need to check that you can solve for a missing angle. Alright, just check you can do one or two. And then hopefully maybe before we finish we'll have a quick chance at checking on cosine rules, so we introduce it before next lesson. Alright?